friends, welcome back to our channel. Today we are going to start with one more topic, combination of resistances. Okay, in this combination of resistances we have two types of combinations. One is series combination of resistances and second one is parallel combination of resistances. Okay, out of these two right now we are going to discuss about series combination of resistances. Okay. And before entering into the topic, I will give you just once brightness is more, some of the bulb brightness is less. Okay, on basis of which combination we will get like this. Okay, right now, in order to identify this, we need to discuss about the topic is series combination and second one is parallel combination. Okay, right now, entering into the series combination of resistances. Okay, and suppose if you observe carefully, there we have different bulbs. Okay, in that bulbs there you can find a small filament in it. Okay, what is the filament? Means which is giving you resistance. Okay, that offers resistance. Some of the filaments are offering more resistance, some of the filaments are offering less resistance. Okay, and here on basis of this what happens to the brightness of the bulb? It may be either more or it may be less. Okay, and right now we are taking different bulbs, electric bulbs. Okay, in that different resistances they offer. Okay, and if you connect three bulbs, we are taking three bulbs right now. In this one electric bulb I am considering, one more electric bulb, three electric bulbs we are considering. Okay, and it is each and every bulb having two terminals, but there is no positive terminal and there is no negative terminal. Okay, two terminals will be. So we can combine together these three bulbs. I am going to connect together in series combination. When we will call it as series combination means here you can connect one end to another end of the bulbs. Okay, nothing but first terminal is connected to second terminal of the bulb, or end-to-end connection. Okay, end-to-end connection, that we are calling it as series combination. Okay, or else you can call the first terminal is connected to second terminal of the bulb and continuously so on. Such combination we are calling it as series combination. Right now, what happened to the bulbs? Here these three bulbs which are connected in series combination, end-to-end combination, we are calling it as series combination. And each resistance of the bulb I am taking it as, this is R1 and this is R2 and this is R3. Instead of electric bulbs, we can represent that with the symbols of resistance. Okay, if you represent with the symbols of resistance, we can represent like this. Three resistances which are connected end-to-end combination. Okay, this is PN and this is QN. Resistance of these three which are, this is R1, this is R2 and this is R3. This combination we are calling it as series combination. Okay, and right now this series combination I am going to connect with the battery through switch. What the changes happens? Okay, what about the current which is passing through all these resistances? What is the potential and what is the resistance offered by these three resistances we are going to find. Okay, right now I am going to take these three resistances and I am going to connect in combination with the cell or a battery. Here we are going to connect with the battery or a cell. Here this is the cell we are considering. Switch, we are considering a device is called ammeter, which is used to find electric current. How much it's flowing in the circuit we can identify by using this. Okay, and here I am leaving a gap. In this gap we need to connect series combination of resistances. Okay, and right now I am taking series combination of resistances. Okay, right now the gap I am taking it as P Q. Three resistances which are connected. Okay, right now this is R1, this is R2, this is R3. Three resistances combination, series combination we connected. If we close the switch, okay, if we close the switch, what the changes happens? You can identify how much amount of current which is passing from positive terminal to negative terminal by using ammeter. The amount of current which is coming from the positive terminal is I, and how much amount is coming back is in the combination which is giving you by ammeter is the same amount. The amount of current coming from the positive terminal, the same amount will be back. Okay, and right now here if you consider what is the potential across the resistance R1, what is the potential across the resistance R2, what is the potential difference across the resistance R3, okay, and what is the amount of current which is in this. Okay, right now we are getting a point here. By using ammeter we can find, okay, what is the amount of current in this. The amount of current in the circuit is remains constant. Right now it is a closed circuit, the amount of current remains constant. First point. Amount of electric current occurring is constant. Electric current remains constant. Simply you can write I is equals to constant. Okay, and what is the potential difference across the resistance R1? Okay, why? Because it is drawing some amount of current. Okay, what is the potential drop across the resistance R2? What is the potential drop across the resistance R3? Okay, if we count the potential difference across the resistance R1, R2, R3, this is P1 by using potential difference. By using voltmeter, we can identify the potential difference across the resistance R1, and by using potential difference across, by using voltmeter, we can find the potential difference across the resistance R2. Similarly, V3 is the potential difference across the resistance R3. You can find the potential difference across the resistance is R1, across the resistance is R2, across the resistance is R3. Okay, and right now I am going to find what is the potential drop across the resistance R1, R2, R3 combined together is V. Okay, if we find the potential drop across this combination, series combination is V. If you observe carefully, what is the potential difference across the series combination? Nothing but V is giving you the sum of potential drop across the resistance R1, R2 and R3. Okay, so that you can write one statement here. Second point you can take potential difference potential difference across complete series combination is V is equals to V1 plus V2 plus V3. Okay, and right now individually we are going to find what is the potential difference across the resistance R1, what is the potential difference across the resistance R2 and R3. Okay, and right now potential difference I am representing with this symbol PD, potential difference across the resistance R1 is. What is the potential difference across the resistance R1 is V1. V1 is equals to, you can write one formula according to Ohm's law, V is equals to IR. So what is the amount of current? I is constant. What is the resistance? R1. So you can write a formula here, V1 is equals to I R1. Okay. Similarly, potential difference across the resistance R2 is, you can write V2. V2 is equals to I R2 across this. Okay. And similarly, potential difference across the resistance R3 is V3. V3 is equals to, you can write I R3. Okay, right now we got V1, V2 and V3. What is the potential drop across the series combination is V. So you can write potential drop across series combination complete series combination is represented with the symbol is V. V is equals to I. What is the resistance of this? I don't know. So I am going to take R effective or R equivalent, okay, or resultant. So I am representing it as R effective, or you can write the equivalent or resultant. Okay, so we got different formulas, V, V1, V2, V3, and we got one formula for that combination of V, V1, V2, V3, potential difference. Okay, V is equals to V1 plus V2 plus V3. We can substitute these four formulas in this. Okay, but we know V is equals to V1 plus V2 plus V3. Substituting all these in this, V is equals to IR effective. So I R effective is equals to V1 I R1, V2 I R2 and V3 I R3. Okay, and here I getting common. Okay, I remains the same both the sides, so they get cancelled. Directly you can write R effective is equals to R1 plus R2 plus R3. Okay, this is the formula which is giving you series combination of resistances. Okay, what is the series combination of resistances? Resistances are R1, R2, R3. Okay, series combination or equivalent resistance or resultant resistance is equals to sum of the resistances which are connected in the series combination. That is giving you effective resistance or series resistance or equivalent resistance. Okay, we got one formula with, okay, R effective is equals to R1 plus R2 plus R3. Okay, this is giving you series combination of resistances. Okay, ఈ వీడియో కనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. ఓకే.